After this lesson, students will be able to determine the percent of increase or the percent of decrease. Do now. Try these two questions on your own, so pause the movie and resume when you're ready. You buy a bike that originally cost $250. It is on sale for 35% off. How much is the bike? Well, first, we need to figure out how much the discount actually is. In other words, what is 35% of $250? Once I know what 35% of $250 is, we can subtract that amount from the original cost of $250 in order to find the sale price. Well, 35% of 250, we can change the percent to a decimal, 0.35, by moving the decimal point 2 spaces to the left. Of is a buzzword for times 250. So now let's do 250 times 0.35. And we get $87.50. This refers to the discount. So if it originally cost $250, now we can subtract $87.50. Notice how I do need to line up the decimal points for addition or subtraction. I need to borrow. And we get $162.50. So the sale price of the bike is $162.50. A store buys a watch for a wholesale price of $60. They mark it up 30%. What is the retail price? Well, we need to figure out what 30% of 60 is in order to figure out what the markup is. So we could either do 0.30 times 60, similar to the way that we did 250 times 0.35, or we can use some other shortcuts. For example, if we know that 10% of 60 is 6, then 30%, which is 3 times 10%, would be 3 times the 6, or 18. So to write that out, for those of you that are more visual, 10% of the $60 is 6. So if I multiply that by 3, or take 3 of those, we find that 30% is 18. $18 is the markup. So we need to add 60 plus 18 in order to find the retail price. So the retail price, one moment, let's fix that. So the retail price of the watch is $78. A percent of change shows how much a quantity has increased or decreased in comparison with the original amount. For example, if an item originally cost $10 and now it costs $20, that is a larger percent of change than if an item originally cost $250 and now cost $260. Notice how in both cases the price went up by $10. 10 became 20 because we added $10. 250 became 260 when you add $10. However, the percent of change is much larger when you're going from $10 and now it's been doubled to $20. Whereas $10 is not so much in comparison with the original cost of our $250. A percent of increase is when the new amount is greater than the old amount, and a percent of decrease we use when the new amount is less than the original amount. In general, percent of change equals the amount of change, which is the difference between new and old, divided by the original amount. Then you change your answer to a percent. So for example, what is the percent of increase from 8 to 13? Well, we need to find the amount of change, which we're going to do new minus old. So new minus old, in this case, would be 13 minus 8 because it went from 8 to the 13. And we divide that by the original amount, which is 8. That's 5/8, which equals 0.625, written as a percentage is 62.5%. Now, since this is an increase going from 8 to 13, we can say that there's a 62.5% increase. In our next example, we're looking for the percent of decrease from 49 to 35. So we do our new minus our old, which is 35 minus 49, and divide by the old, 49. Well, 35 minus 49 is negative 14 over 49, which I can reduce both by 7 to get negative 2/7. Negative 2/7, when you divide, gives you a very long repeating decimal, 0.285714. But we're looking for a percent. So we'll move our decimal over 2 spaces and we'll have to round. So we can say that it's approximately a 28.6% decrease. In your first year as the soccer team's goalie, 25 goals were scored against you, followed by only 15 goals in your second year and only 10 goals in your third year. What was the percent of decrease in the amount of goals scored against you from the first to the third year? So we do the amount of change, which is new minus old. In our third year, we had 10 goals scored against us, and in the first year, there was 25. Divided by the original 25. So this gives you negative 15 over 25, or negative 3/5. Well, negative 3/5 equals negative 0.6, or negative 60%. When you have a negative, that's an indication that this is a percent of decrease. So we can say that this is a 60% decrease. And our sentence would be, there was a 60% decrease in the number of goals scored against you from the first to the third year. Now you try these two questions. Pause the movie and resume when you're ready. The price of a skirt decreased from $32.95 to $28.95. Find the percent of decrease. Well, we find the amount of change, which is new minus old. 28.95 minus 32.95 over the original, 32.95. 28.95 minus 32.95 is negative 4. If I move this decimal over twice, I can also move this one twice. And now I need to divide 400 divided by 3,295. So we'll have to add a decimal and a 0 since 3,295 does not go into 400. This goes in once. And we subtract. And you get 705. Bring down the 0. This goes in twice and gives you 6,590. We subtract. To get 460. And we'll have to bring another 0 down. And this goes in one time. And when we subtract, we get 1305. And we could continue along with this process, but we'll say that there is approximately a 12% decrease. There was approximately a 12% decrease in the price of the skirt. Now, one way that you can always check your answers is to now go back and see, well, what is a 12% decrease from our original cost? So for example, if I take my $32.95 and I multiply it by 0.12, which is 12% written as a decimal, that would give me 12% of 32.95. So let's try this out and see what happens. Oops, I put my decimal in the wrong place. So you get 3.9540, which written as money would be about $3.95. Notice how our cost of the skirt decreased by $4. Well, $3.95 is close to $4, and since we rounded, that accounts for that slight difference. So the price was approximately 12% less. Now for our next one, between 1940 and 1980, the federal budget increased from $9.5 billion to $725.3 billion. What was the percent of increase in the federal budget? Well, first we're going to find the amount of change. The amount of change is 725.3 minus 9.5. We do need to line up the decimals. you get 715.8, which is the amount of change, and we need to divide that by the original 9.5. I can multiply both by 10, so I have 7158 divided by 95. "95 goes into 715 7 times, which gives 665, and when you subtract, you get 50. Bring down the 8, 95 goes into 508 5 times, which equals 475. And when you subtract, you get 33. Add a decimal, bring down the 0. 95 goes into 333 times, which gives 285. And there are 45 left over. Bring down the 0. 95 goes into 450 4 times. And now that we have 2 digits after our decimal point, we can pause, because in order to change this to a percent, I would move the decimal over twice. So we can say that there was approximately a 7,534% increase in the federal budget. Now let's look at these similar figures. Triangle ABC is similar to triangle DEF. What is the scale factor? Well, first of all, let's figure out our corresponding sides. So just to be safe, I'll look at my letters up here as well. A, B are the first 2 letters, so that'll be blue, which corresponds with the first 2 letters in our second triangle, DE. Next, BC, which corresponds with EF. And finally, AC, which corresponds to DF. Our scale factor is the ratio of new to old. So our scale factor is 14 over 8, which can be reduced to 7/4. And that's the scale factor. What is the percent of change, and is it an increase or a decrease? Well, the percent of change, we're doing new minus old, so 14 minus 8 over the old. 14 minus 8 is 6 over 8, which can be reduced to 3/4. 3/4 is 0.75 or 75%, and since we are going from smaller to bigger, this is an increase. 75% increase. And finally, we're asked to find x. So I start by creating a ratio with my pink segments, x over 12 inches, and set that equal to a ratio of other segments that we know to be true, which we see 14 and 8. This can be reduced, so we have x over 12 equals 7/4, and we can either use cross products or equivalent fractions. Since 4 goes into 12 3 times, I can multiply 7 by 3 in order to get my x, which is 21. And therefore x is 21 inches. You try this question on your own, so pause the movie and resume when you're ready. What is the scale factor? Well, the scale factor is the ratio of the corresponding sides, new to old. So 8 over 10 which reduces to 4/5. What is the percent of change, and is it an increase or a decrease? Well, we'll do our new minus our old over our old, which gives us -2/10 or -20%, which means that it's a 20% decrease. Since our answer was negative, and we can see that we did go from a bigger triangle to a smaller triangle. And finally, find x. So we'll go ahead and use our proportions. We know that x corresponds with the 8, and we set that equal to the ratio of 8/10, which reduces to 4/5. And then we can use cross products. So 5x equals 32. Divide both sides by 5. And x equals 6 2/5, or 6.4 centimeters.